Okay, start recording. Okay, let's see. Okay, today we will continue with the lessons for linear programming. Okay, let's see. So from your file, you have chapter 12, linear programming. Okay, so from this linear programming here, we're going to look at how to actually solve optimization problem. Okay, so if you look through the chapter learning objective here, okay, so apply appropriate techniques to support short-term decision. Okay, so in indicated syllabus content, make or buy decision, discontinuation decision, multi-product break-even analysis, okay, and so on. So this is actually to do optimization. Okay, but we can actually solve this question by using Excel solver. But the problem here is, okay, you are going to sit for exam, therefore you need to know, at least need to know how to solve them manually. Okay, so therefore over here, let's see, okay, what are the things that you need to learn. Okay, introduction to linear programming. Okay, the feasible region is defined by the area contained by all the constraint lines in the graphical decisions of a linear programming problem. All feasible combinations of the output are contained with or located on the boundary of the feasible region. So what does it mean here is, okay, you're going to get a, a graph that maybe looks like this. Okay, this one is one line, then this one is another line. Okay, so and the region here, okay, over, well, we call it a feasible region. Okay, this one we call it. So visible region means all the possible answers. Visible region. Okay, and over here it says that, okay, located on the boundaries of the feasible region. Usually the answers of your optimization according to your syllabus will be at the intersection point. Okay, so we need to know how to actually find this intersection point. Okay, slack is the amount of each resources that will be unused in the specific linear programming solution is implemented. Shadow price is the increase in the value that would be created by having one additional unit. So if when you increase one unit, so what's going to happen to the cost and so on. Okay, so in single limiting factor case, products are ranked according to the contribution per unit by their linear limiting factor. When there are multiple limiting factors, a mathematical technique called linear programming is used. Okay, so when you have more than one line, so we use this linear programming technique. Of course, the one that you're drawing here is a graphical technique. The technique involves converting these limiting factors or constraints and the variable into equations. So make it into line equations. So these are equations 1. Okay, this may be equation 2. Decision can be reached through solving simultaneous equations. So this one, we want to find the points and actually solve the simultaneous equation, or through graphical representation. If you have a nice graph, okay, maybe you have a nice graph that actually with the line like this, okay, graph, line, okay, or horizontally line, okay, line. So maybe you can actually read the coordinates, okay, then you can actually read the coordinate to actually get the answer. So the coordinate that we want to read, or maybe I want to read from here. But not, of course, not all the time there will be a graph question. So therefore, you still need to know how to do it mathematically. Okay. Then, therefore, you are required to know how to solve. Okay. So there are some steps here. Define the variables, okay, usually x and y, okay. So variable x and variable y, okay. Then maybe the units of product B, okay, product A, product B. Identify the objective function. Objective function, usually the total contribution to be earned from the production, okay. So therefore, this objective function can be a maximum or minimum problem. Okay, so the most common thing that we are talking about here, we want to maximize profit, minimize the cost. Okay, identify constraints as equations. So the constraint will be all the different lines, the black line that we're going to draw. Plot the constraint on the graph. Okay, so depends on whether we use graph or not. Okay, using graph will be the fundamental way. And find the optimal solution through simultaneous equation. Find the coordinates. Okay, so we want to find the coordinates. Okay, or by drawing to see the to read the table. Okay, to read the graph. Okay, so the best part is to just we solve it by using example. Okay, better to learn from example. Okay, therefore let's see how to actually do it by example. Okay, then let's see. Okay, so let's look at this example. Okay, Saga company produced 2 products in three departments, A, B, and C. The time per unit required in each department, the hour available in each department, and the contribution per unit for each product are presented below. So there are some information actually given over here. So department A, department B, department C. Okay, so contribution per unit. Okay, product X hour per unit. So what does this segment actually means? Okay, what does this segment actually means? So you need, okay, 7 hours from department A to complete 1 unit of X product. Okay, of product X. Okay, of product X. So therefore, it is important that you actually know how to read this information. Okay, so contribution per cost. Okay, so let's see what are the things that we actually can ask from here. Okay, then let's see. Okay, so we want to find its constraint. Okay, we want to find its objective function. Okay, so objective function. Okay, so therefore over here, contribution means profit. Okay, so we want to maximize profit. So objective function will be maximize 5x plus 10y. We want to maximize 5x plus 10y. Okay, so that will be the objective function that we want to do. So, and over here, that means over here, the x will be x amount of the product x and the y amount of product y. Okay, so this is x representing the quantity, of product x, and y representing the quantity of product y. Okay, then from here, what does this 11,000 actually means? Okay, the available hours that we have from department A. So over here we have three constraints. So we have a 7x plus 10y must be lesser equals to 11,000. 2x plus 10y must be lesser than 9,000. Okay, then department C, we have 13x plus 6y will be lesser than 14,000. So this 7x plus 10y will be representing the total hours that you need for product X and product Y. Okay, so 7 out for each X product you need 7 hours. For each Y product you need 10 hours, right? So total hours for total hours will be 7x plus 10y, and you have available hours only up to 11,000. So therefore we actually write it in this way. So this will be your constraint. Okay, that will be your constraint. So we have our objective function 5x plus 10y, and we have our constraint. So the thing is, how do we actually maximize our objective function? Okay, so how do we actually maximize our objective function? This comes to drawing of graph. Okay, let's see. Okay, let me draw the graph first. Okay, so over here, okay, let me draw the graph. So I'm going to draw the graph of y equals to 11. Wait, let me key in minus 7x, okay, over 10. Okay, so then we have graph of graph. We have a second constraint, which is minus 2x over 10. Okay, then we have third graph. Please wait for a while. Let me finish keying in the thing first. Okay, 14,000 minus 13x over 6. Okay. Okay, graph D equals Q, apply. Okay. Okay. So for information, I use a graph software to actually help me to get the graph done. Okay, and this is then I get these 3 lines. Okay, I get these 3 lines. So for your information, we have the three lines. Okay, over here we have the one that with the 7x plus 10y lesser equals to 11,000. Therefore, we have this 11. This is 1100. So this is our 7x plus 10y equals to 11000. Okay, then 2x plus 10y, okay, let's say equals to 9,000. So this will be here. 2x plus 10y equals to 9,000. This will be my second line, and this is my third line. 13x plus 6y equals to 14,000. Okay, so over here, okay, the answer that actually satisfies this equation will be fall under this region. Okay, will be fall under this region. Of course, maybe you will be asking that uh, do I, if I how do I actually draw the graph? Okay, so please understand that this is already a P1 or CIMA P1, so you will be expecting to have at least SPM knowledge. Okay, so drawing graph should be something that no problem for you. Okay, drawing the straight line graph. But if you do have problems to actually draw the graph, okay, using graph paper, please state so. But since your exam is actually objective, okay, so therefore we still have some tricks for you to actually take care of your answers during exam, such as we are for your to fit with your exam questions. As I say, usually the answers will be fall under the interceptions of the line. Okay, interceptions of the line. So the questions arise here is how do we actually do the tricks? Okay, so but knowledge-wise for theory, you are actually able to see that this is how you actually can get the visible region of the graph. Okay, then after that, okay, now this is time for us to find the solutions. Okay, so if you have the graph, of course you can actually read the graph to actually get the coordinates. Okay, but over here, since we don't have a graph, okay, how are you going to do it? This is the time that you're going to use your calculator. Okay, this is the time that you're going to use your calculator. So the calculator that we have, okay, so over here, let's call this as point A. Let's call this as point B. Okay, so let's see the calculator model. Let me get a picture of the calculator. Okay, OEX. Okay, so the calculator that we're actually referring is this. Okay. Okay, continue. Okay, this is the file. This is the calculator that we will be using. Okay, so how do we actually use this calculator then? Okay, so over here, first we press menu. Okay, this is menu. So after menu, you move around the cursor. Okay, then you will see equations. Equation function. Okay, so you select that. Then after that, you select how to select. You press equal button. Okay, after that, you press simultaneous equation. Simultaneous equation. Okay, so you press 1. Then after that, the question asks how many unknowns do you have? So you only have one variable x and y. So we press 2. Okay. Then after that, you'll have the x and y appear here. So for A, so we're going to key in like this. We're going to key in. A is intercepting from 7x plus 10y and 11,000. 2x plus 10y equals to 9,000. So we're going to press 7 equal 10 equal 11,000 equal, then followed by 2 equal 10 equal 9,000 equal. So follow 7 equal 10 equal 11,000 equal 2 equal 10 equal 9,000 equal. Okay, then you press equal again. So it gives you x equals to 400, y equals to 820. What does it mean here? This is your coordinate A. 400 and 820. Not finished yet. Okay, not finished yet. Okay, because we still need to solve for the B. Okay, we still need to solve for the B. So for B, So B here, you see there is an intersections of 7x plus 10y equals to 11,000 and 13x plus 6y equals to 14,000. Therefore, we key in like this: 7 equal 10 equal 11,000 equal 13 equal 6 equal 14,000 equal. So let's follow. 7 equal 10 equal 11,000 equal 13 equal 6 equal 14,000 equal. So you press equal again. So you have x equals to 9250 over 11, and you have y equals to 5625 over 11. Okay, so this one is about 511.36. Okay, so 9250 over 11 will be about 840.9. Okay, so therefore this coordinate B here will be 840.9 and 511.36. Okay, so this is how we actually use our calculator to actually get the coordinate of A and B. Okay, which actually fulfill our simultaneous equation steps. Okay, you can actually utilize your calculator. Okay, don't forget our objective is to maximize the answer. Okay, let's see how are we able to maximize the answer. So which will be our maximum solutions. So for A, so our objective function, okay, we have a 5x plus 10y. So what we're going to do is I'm going to substitute 5 times of the coordinate A, 400, 820, 400, then plus by 10 of 820. Okay, so press your calculator. So 5 times 400 plus 10 times of 820, you have a 10200. Then for point B, okay, our 5x plus 10y will be equals to 5 times of 9250 over 11, okay, plus 10 of 5625 over 11. Let's see what is the answer that we get. Okay, so I will have 5 times 9250 over 11 plus 10 times 5625 over 11. Okay, I will have a value of 9318.18. So it's actually very obvious that this is the biggest. Okay, this is bigger than this. Therefore, our maximum profit that we can be is 10200 by produce. Okay, produce what? Produce 400 of product X and 820 of product Y. Okay, so then let's see. This is the end of this example. Let's see what other things that we need to discuss. Okay, then from here, okay, then maybe the next part you would like to know about the limitation. Okay. Okay, you need to know some theory. Limitation of linear programming: the variable may not necessarily be linear, so it may not be a straight line. It's assumed that can be only be one objective functions. Complexity increases as the number of variable increases. So if let's say you not only have a variable x and y, and it's assumed that circumstances remain constant. Okay, then another thing that you have to take care is the shadow price. Okay, so subscriber resources may be made available through buying them in. Okay, we may need to pay some money. Okay, to get more resources. These resources may be available at a premium above a normal price. Maybe you are actually asking more than required. Okay, shadow price is the maximum premium that a business will pay for these resources. This is the extra contribution that can be earned from having an additional unit of the resources. So therefore, we are talking about additional contribution. Okay, we are talking about additional contribution. So therefore, if let's say based on the question that we have earlier, okay, so what if we have, okay, referring to the information of Saga company, calculate the shadow price of extra hour in department A. Okay, so therefore, if you spend 1 extra hour in department A, how does it going to affect your calculations? Okay, how does it going to affect your solutions? How does it going to affect your maximum your objective function? Okay, so over here, so therefore, okay, over here you will have earlier you have 7x plus 10y equals to 11,000. Okay, and 2x plus 10y equals to 9,000. 2x plus 10y equals to 9,000. This one gives you the solution of x equals to 400, y equals to 820. Okay, so this is from earlier, from earlier. Now you have 1 extra hour for the department A. Yeah, okay, so therefore now your constraint change into 7x plus 10y equals to 11001, and 2x plus 10y equals to 9,000. This one remain unchanged, okay, due to the equations. Okay, so this one is actually remain unchanged here. So what we're going to do now is, okay, still going to solve the simultaneous equation. Okay, again, solutions will be press calculator. Okay, press calculator. So I take out my calculator, I press. Okay, now I have a 7 equal 10 equal 11001 equal 2 equal 10 equal 9,000 equal, then you press equal again. Okay, 7 equal 10 equal 11001 equal 2 equal 10 equal 9,000 equal, then press equal again. You have the x value equals to 400.2, and you have the y value 819.96. Then from the solution that we have here, we put inside our contribution function or objective function. Okay, your objective function is 5x plus 10y. So we have a 5 times of 400.2, okay, plus 10 times of 819.96. So I calculate inside my calculator. So 5 times of 400.2 plus 10 times of 219.96. So you will have a 10200.6. Okay. So over here, what does it mean actually? Okay. The original solutions provide 10200.00. The new solution provide 10200.60. Okay, that actually tell you that, okay, the by increase of 1 hour in department A, contribution will increase by 0.60 cents. Of course, the solution can be increased, can be decreased, depends on the questions. Over here, the new solution is more than. Therefore, we actually can pay will be increased by 0.60. So that means, okay, so if you want to, in other words, okay, the shadow price is 0.60. The shadow price is 0.60. Okay, or we can also interpret it as, in order to increase 1 additional hour in department A, you need to pay your cost by additional 60 cents. Okay, for every increase of 1 hour. Okay, don't care whether it's a labor cost or the machine cost or the electricity cost or whatever. Okay, there will be depends on the equation given. So the shadow price will be 0.60. Okay, and this is all about linear programming optimization questions. Okay, hope that you are actually okay and practice by using your calculator. Thank you very much.